Everybody in Southeast Texas survived the hurricane. Hope y'all are all doing well. So this is kind of odd because typically I teach in person and I have feedback, but I can't see anybody, I can't hear anybody. So if you want to ask questions, Kenya will jump in and ask the questions. Just put them in the little box that says Q&A. It's either going to be at the top of your screen or at the bottom of your screen. So throw out questions if you have any. I'll try to get to all of them. And like I said, or like she said, if I don't get to all of them, then y'all are welcome to email me, text me. A lot of y'all are on Facebook. Y'all can contact me there through Messenger, however. So just get a hold of me. There is my contact information. And it is actually wrong. That is sbcglobal.net. I spelled global wrong. So just pay attention to that email if you try to email me. So, but anyway, we will go ahead and get started. This is electrical inspections according to the SOPs. That photo on this first page is a Leviton panel. They're relatively new. They've been out a year or two. I did not go into detail with them. I just threw it up there. I would suggest that everybody go and research these panels. They are built different internally. The breakers are different. The way the neutrals and grounds are done is different. So I would strongly suggest you just go in and research them and try to trace everything. Trace the bus bars, the neutrals, the grounds, the way that they bond different things together, the way they bond the bus bars together, the way the panels bonded is a little different than your typical Square D or Siemens or GE. So just take a little time this evening, if you will, and study those a little bit. So anyway, with that, we will get started. And just this presentation does not cover all the SOPs related to electrical inspections. I mean, that would take days. So we just took out enough to cover a 2-hour class. Some of it is very general, some of it is very specific, some of it's very basic, but I hope you get something out of it. And once again, there's my information. Contact me if you need something after the class tomorrow, over the weekend, and I will get back to you. So here we go. So first thing we're going to talk about is inadequate clearances, which comes up quite often, I find. The SOP says that panel boards are not, you should report panel boards that are not appropriate for their location, such as closed closets, bathrooms, or if they're exposed to physical damage. Any of them that are not accessible or do not have minimum clearance of 36-inch clearance from the front of them. So in a closet, you got foliage blocking them a lot of times. Behind pool equipment, pool guys don't know electrical codes a lot of times, so they don't know that there's a required clearance. Fences blocking access. We've got some examples here. This image on the far left is directly from the IRC. So if you go onto the electronic IRC, you can pull that image up and take a screenshot of it, and there you have the image. I actually use that image in my reports whenever I find inadequate clearances. Second picture, foliage blocking that. Now that's not a service panel, but it's still a panel. You got to get in there to work on it. You've got to push the foliage out of the way so you can get to it. Fencing guys typically don't know electrical codes, so they just ran the fence right up to the meter. Brand new construction. This next one is a video, just kind of explains what I was looking for in this panel. And yes, I did get to it. I worked over this pile, took the cover off, obviously, but here's a few things I noticed in here. In this garage, and it's blocked by a bunch of personal belongings. I've been able to get the cover off, but clear access should be provided. There's several issues in the panel. This is a 2004 construction. We've got the conduit that doesn't extend into the panel, so the bushing isn't connected by current standards. That should have a bonded bushing. You've got a knockout here that's missing protection on the wire
two more up here the same way. These were probably added after construction. The wiring going through this one large piece of conduit should go through these smaller knockouts. The bond screw was not installed, so the neutral and ground bus bars are not bonded to the panel. You've got a white wire here, here, and down here that should be re-identified. Being that it's 2004, you should have arc fault breakers for the bedroom circuits. There's two of them. I'll have to check the labeling on it. But there you are. And by current standards, these lugs up here should have barriers on them to prevent accidental contact.
All right, so several issues with that panel, and I find that that's very typical of what would have been done in 2004. So inadequate clearances. The one on the left, they built a trellis over the panel. And this was out in Hempstead, which is out in the country. And the seller was there. One of the first things they said is they had about a 400 square foot section that was a crawl space. And first thing he says is, I don't want you going into that crawl space because we've killed several copperheads around there. So I said, okay, no problem. Then I find this electric panel that I have to crawl into with copperheads in the back of my mind. So I carry a long screwdriver for doing termite inspections. So I beat around on the ground and apparently ran everything off because I didn't see anything, but clearances were not provided. I got in there and got it inspected. The one on the right, same house, that panel's inside the kitchen pantry. So inadequate clearances, it's not supposed to be in a storage closet. So you could consider that a storage closet. You're storing food. It could be very easily blocked. And as a matter of fact, I did have to remove some stuff. I think a small step stool and a vacuum cleaner to get to that panel. So wasn't a clear path to it. All right, SOP says that we shall report deficiencies in the absence of a main disconnect means. It can be a single main or it can be up to 6 breaker throws, commonly called a split bus panel. The one on the left, you have a main breaker that meets it. To jump to something else on this same slide, because that's what we do when we open an electric panel. We're not looking for one thing, we're looking for everything. We're missing a common trip tie on that top left breaker. A multi-wire branch circuit or a 240 volt circuit requires the breakers to be trip tied. The one on the right is a split bus panel. This was Ashley Miller's picture I stole off of Facebook, but you can see the wiring going down between here and straight down. That's the split bus. So if you turn these 4 off, actually if you turn this one off, it kills everything down here. If you turn all 4 of these off, everything in the panel's dead. So obviously you're missing trip ties. It looks like they actually broke these for some reason. Missing trip ties here, but if you had trip ties on all these, it would meet the 6 throw rule. So it would be 6 or less. Double taps on main lugs. These smaller wires, even if they were the right size wires, these lugs are likely not designed to be double tapped. It turned out that these wires were going to pool lights, 150 amps to a pool light. So anytime you see double taps, especially on the main lugs, call it out. There are instances on breakers where they can be double lugged, but those breakers have to be labeled. So call out any double taps on the main lugs or any other areas. We'll talk about that a little bit more. All right, 2 different panels here. We'll talk about the one on the left first. And y'all may see other issues that I'm not calling out right now, but this is just in general, when you take off a panel. This is from 1999. So We were just talking about double taps. You've got almost every neutral has 2 or 3 wires in it. Neutrals cannot be double lugged. Neutrals are 1 wire per lug, just like this bottom one. Another issue here, you've got a white wire being used as hot that should be re-identified. Something also that I look for, this is a back-fed breaker. It's got a hold down, it's got a screw here. That's required on a back-fed breaker, and I think we'll get into that a little bit more. I've got some examples of some different types of hold downs, but look for this to make sure it's there. Trek says that we're to call out antioxidant on these lugs, on the aluminum wiring. I call it out and say that most manufacturers do not require it. However, Trek requires us to consider this a deficiency. So I note that. All the wire goes through one knockout here. Now on these exterior panels, there's no other way to get around it, unless, I guess you could run conduit from all the little openings down here, but that would look kind of silly. So that's technically wrong, but that's the way the panel's designed. Same way on the one on the right. So this one's 1982, and it's almost the same identical deficiencies. You've got double taps on the neutrals here, and some of the neutrals and grounds are under the same lug, and that's still considered a double tap because the neutral cannot share a lug with another wire. White wires, again, not re-identified, very common. These are canned comments that I have in my reports, which I'm certain most of you do, just because it's a very, very common issue to call out. So very typical of a 1999 and 1982 panel. However, our SOPs require us to call a lot of this stuff out.
Derrick, let me interrupt really quick. We have a couple questions before we go on further.
Okay.
What's the name of the panel that you mentioned at the beginning of the presentation?
That is a Leviton panel.
Okay, and the second question, can you double tap grounding wires?
Usually you can, yes. It will depend on the panel manufacturer and if the lug is rated for, but normally the grounds can be double lugged. Has to be the same size wire, and some of them will even allow 3 wires. If it's 2 wires, 3 wires, it has to be the same size wire. You can't put a number 12 wire with a number 10 wire. But typically grounds can. And the larger lugs are the ones usually that will not allow double or triple tapping.
Okay, last question, just so we can continue. It says, I see the issue regarding double taps, but can you explain why is it an issue and what are the risks?
Okay, so one issue would be, so if you had a multi-wire branch circuit, so possibly this one on the left here, this, no, that's a 240, sorry. So a multi-wire branch circuit, let me see if I have one in here. Possibly this right here. So this and this share a neutral. So say this was going to a ceiling fan, and the bottom leg, the red wire maybe fed the fan, the black wire fed the light. So you've got 2 120-volt circuits. If for some reason the neutral feeding these are double tapped with, say, the neutral feeding this breaker down here, and you're working on this circuit down here, you disconnect the neutral from the breaker down here, inadvertently disconnecting the neutral on here, you run the risk of turning that 120-volt circuit into, or the 2 120-volt circuits into a 240-volt circuit because you took out the neutral. So there may be a path through there somewhere that could turn that into 240 volts. When you run 240 volts through a fan or a light bulb, the light bulb's probably going to blow. So that's one risk. Another risk is disconnecting it and not having a path for the circuit that you're not working on. You inadvertently disconnect electricity to an alternate circuit if you're working on another. So I hope that helps. Hope that answered the question. All right, a sub panel. This is code check. I'm sure most of y'all have seen this diagram before. So we'll talk about, this is a question that comes up a lot on Facebook. do you separate the grounds and neutrals? At the first disconnect, grounds and neutrals should be bonded together. In other words, in this panel, this little strap here should be connected to this. If it was a main panel, the sub panel, you disconnect it. And there's different ways of doing this, obviously, but this is this image. Anything after first disconnect, the grounds should be bonded to the panel and the neutrals should be isolated from the panel. You see how there's this little plastic underneath here at the bottom and also at the top here? So this bus bar is not in contact with the panel. It's isolated. You've got a neutral coming in from the main panel. You've got a ground here coming in from the main panel. So your grounds go here, neutrals go over here. And here's the actual panel that they've done. So you've got 4 wires coming in. Here's your ground, comes over here to the right and down, and it connects to this ground bus bar. Here's your neutral. It's kind of hard to see, but it snakes around and it ties in right in the middle. And then it splits off and goes this way and this way, down here and down here. So if you'll notice, the bond screw's gone. That isolates your neutral bus bars from the panel. If you put the bond screw in, that green screw, then your bus bars here and here will be bonded to the panel, and it should not be bonded to the panel in a sub panel. So that's the simplest way to look at it. Your grounds are out here, directly connected to the panel. Your neutrals are here, isolated from the panel. And it should be a 4-wire system. 1, 2, 3, 4, or we'll count it down here. 1, 2, 3, and then here's your main coming in 4. All right, double taps we were talking about just a little while ago. So you've got some of these down here double tapped, like right here. Here's a blown up picture of it, you can see. What you want to look for is this right here. And it depends on the size of wire and the type of wire. So aluminum, it's 1. You cannot put, hang on one sec, I got to move something. I don't know if y'all can see that or not. With aluminum or copper, you can have 1. With copper, you can have 2. You got 2 wires here. That means you can put 2 of them on this breaker, and that is right. It's on these breakers. I can't see that small. It's in this area is where you want to look. But this is what you're looking for right here. If it doesn't have that, then it is not rated for 2 wires. All right, also with labeling, the panels should be labeled. If it's not labeled, how are you going to know if the air conditioner has provided the right size breaker? So this is a comment that I've used for years. I think I got this from Clay Collins, and the wording is very similar to what it says in the NEC. It simply says that the breakers are not labeled. So they've got to be labeled. If they're not labeled, call it out. And there is some misconception that got started a few years ago that the labels have to be typed. They can be handwritten. It needs to be legible. The requirement for typed labeling is when you have 2 or more nominal voltages. So in other words, if you had 480 coming in here and 240, then it has to be clearly typed, can't be handwritten. So residential panels for the most part do not have to be typed. Handwritten is fine, as long as it's legible and spelled somewhat correctly. All right, GFCI protection. This is a chart. I'll put this on Facebook later. So if anybody wants it, it kind of shows you when GFCIs were required in what different areas. And we're going to go over some of these areas. We're not going over all of them, We're not going over swimming pools and a few other places that we just, like I said earlier, we couldn't fit everything into this presentation. So we're going to go over a lot of this stuff. And, but like I said, I'll put this, and I've got another chart very similar to this for AFCIs. I'll put both of those on Facebook later so y'all guys can grab them. All right, per your SOPs, absence of GFCI protection is, or you are to note the absence of GFCI protection in all bathroom, garage, outdoor crawl space, unfinished basements, kitchen counter receptacles, and receptacles that are located within 6 feet of the edge of a sink. And we'll talk about all of these right quick, briefly. And this is comparably to our SOPs. This is what the actual NEC says. And you'll notice that 1 through 7 are in the NEC. Number 10, laundry area. I'm going to talk about that for a little bit. It's not required in your SOPs, but I'm going to discuss it a little bit. So that's why it has the asterisk, because it's not required to be reported per our current SOP. All right, and the ground fault circuit interrupter shall be installed in a readily accessible location. That's per the NEC 210.8. It can't be in a ceiling. It can't be under a bathtub. And we'll discuss, I've got a couple of slides later, we'll discuss some other areas where it can't be, but it has to be readily accessible. And readily accessible per the NEC says, capable of being reached quickly for operation, renewal, or inspections without requiring those to whom access to requisite to take actions such as use of tools other than keys, to climb under, to remove obstacles, to resort to a portable ladder, and so on and so forth. And notice it says a portable ladder. It doesn't say a ladder, because you could have an attic ladder that conceivably could require a GFCI up in the attic. And that is coming, by the way. Behind a washing machine, we've got these great big top loader washing machines that you can't reach behind. You got to jump up on top of just to see behind. You can't put a GFCI behind there. That's not readily accessible. It says not to climb under or to remove obstacles or climb over. So if you can't walk up to it, open a door, open a cabinet and push it, it's not readily accessible. All right, bathrooms. It's any receptacle in a bathroom, whether it's within 6 feet of a sink or over a countertop, it doesn't matter. If it is in the bathroom, it is to be GFCI protected. Below a countertop, we see them near toilets sometimes for some reason. Maybe people sit on the pot, blow drying their hair. I wouldn't know anything about that. A television over a bathtub, that's required to be GFCI protected. But once again, remember the GFCI is supposed to be accessible. So if it's a 10-foot ceiling, that GFCI should not be located up behind the TV 9 feet above the floor. That's not accessible. That's not readily accessible. So make sure that that GFCI reset is, it could be tied into the bathroom counter. It could be tied into the, to another GFCI on a separate circuit in that bathroom. The lights in a bathroom can be connected to a GFCI circuit if that circuit serves that bathroom only. If that circuit goes outside of the bathroom, the lights cannot be on that GFCI circuit. What is considered a bathroom? According to Article 100, a bathroom area is an area that includes a basin, as well as one or more of the following: a toilet, a urinal, a tub, a shower, bidet, or similar fixture. So a sink and another fixture. Garages. And it's not just garages. Any accessory buildings that have a floor located at or below grade level not intended as a habitable room and limited to storage areas, work areas, and similar areas of use. What I would suggest is if you think that gasoline could be stored in it, or lawnmowers, or lawn equipment, or any type of rakes, shovels, it's a garage. A barn, an outbuilding. Now, it says if it has a floor, so a barn may not technically be required to have it, but is a dirt floor a floor? I recommend them. Most barns I come in contact with do not have GFCI protection. You have to have them in the walls, in the ceilings for garage door openers, but once again, that GFCI cannot be in the ceiling because it's not readily accessible. What about a dedicated receptacle? Years ago, a dedicated receptacle, a single receptacle, not a duplex receptacle, was not required to be GFCI protected. 2008 NEC changed the standard and said every receptacle in the garage. The reason they changed it is because people would come in and put a three-way adapter in and plug several things into it. So the single receptacle was no longer a single receptacle. So anything in the garage should be GFCI protected. But what about a freezer? Still has to be GFCI protected. That's the owner's decision if they want to do that. If they want to switch it out after you leave or not upgrade it, that's their call. You should call out any receptacle in the garage as needing GFCI protection. What about that little box for the internet? A lot of companies put the internet box in the garage and they plug into it. It still has to be GFCI protected. So I think we've covered that. If it's in the garage, it needs GFCI protection. There's a few examples. And once again, the reset must be readily accessible. None of these were GFCI protected. You got one in the ceiling for the garage door opener. You got one on the wall here. And there's one under the cabinet here and here. None of them were GFCI protected. Now that was an older home, but still your SOP says you are required to call out the absence of GFCI protection in a garage. It doesn't say if it was built before such and such date. It says if it's not there, call it out. Outdoors, there are some exceptions, but they're typically not going to apply to residential installations. So outdoors, back porch, at your air conditioner, at the front porch, at a balcony, and a balcony is required to have a receptacle. And typically a balcony is going to be considered outdoors, even if it's screened in, should have GFCI protection. Christmas light receptacles up in the soffit should be GFCI protected. Those are normally going to be on a switch, and I find normally that the GFCI is either at the breaker or right next to the switch. So practically anything outdoors. Like I said, there are exceptions. If you come across some strange installation, take a look at 210.8. That's where the GFCI protection requirements are, and you can see the exceptions there. Crawl space. I very, very rarely see a receptacle in a crawl space. In fact, I don't hardly even do crawl spaces anymore. They have to beg. But any receptacle in a crawl space should be GFCI protected. I have seen a couple of furnaces in crawl spaces, and that receptacle that is provided for the furnace is required to be GFCI protected. Unfinished basements. This is the only photo I have for it because I've not seen an unfinished basement. We just don't have them here. So I'm just going to roughly go over this. And it's pretty simple. If the basement's unfinished, then the receptacles are required to be GFCI protected. If it's a finished basement, then it's technically a living room, or it could be a bedroom. And then you would follow those requirements for AFCI protection. Kitchens, where receptacles are installed to serve the countertop surfaces. So that one on the end of the island serves the countertop. anything above the countertop, and I'm sorry, I thought I had another photo in here, but obviously I don't. Anything above the countertop between the cabinets in the backsplash, any of those strips that you find builders putting on the underside of cabinets now should be GFCI protected. Anything intended to serve the countertop. So most small appliances have a 2-foot cord. So practically anything that you can set on the countertop and plug in, if it will reach the receptacle, then it should be GFCI protected. Sinks. There's been some confusion on this, and I hope I can clear it up. Where receptacles are located within 1.8 meters or 6 feet from the top inside edge bowl of the sink. It does not say 6 feet from a water source. It does not say 6 feet from a hose bib. It does not say 6 feet from an ice maker connection. It doesn't say 6 feet from a faucet. It says 6 feet from the edge of the bowl of the sink. So don't get confused when you have a refrigerator that has an ice maker. That does not require GFCI protection because of the ice maker connection. Now, if that receptacle for the refrigerator is within 6 feet of the edge of the sink, then that receptacle is required to be GFCI protected. So it's not a water source, it's the edge of the sink. The other thing that I've seen confusion on is this is in addition to all of the other rules. So in other words, the 6-foot rule doesn't apply to kitchen counter receptacles. If it's over the kitchen counter, if it's meant to serve the kitchen counter, whether it's 6 feet, 8 feet, 10 feet, or 12 feet from that sink, it should be GFCI protected. The 6-foot rule doesn't apply to bathroom receptacles. If it's in a bathroom, it shall be GFCI protected. The 6-foot rule is to be applied to a receptacle that doesn't meet one of the previous 6 requirements. For instance, this receptacle on the left below the countertop is within 6 feet of that sink. That's required to be GFCI protected. It doesn't serve the kitchen countertop. That's a bar. It serves the dining room or breakfast room, whatever this was. But it is within 6 feet of the sink. That was the intent of this rule, was this guy right here. Some other receptacles have fallen into that as a result, but that was the intent of this rule, this guy right here. Here's another one, 6 feet. I carry a 6-foot tape measure with me in my front left pocket every day. So I can measure. If it's less than 6 feet, I note it. This one here serves the countertop, so no matter if it's within 6 feet or not, it's required to be GFCI protected. This one doesn't serve the countertop, but it's still within 6 feet. And it's not a straight line through it. It's a path around. So it would go to here, you measure here to the other side of the bar and then down to the edge of the sink. It's not a straight line through, it's up and over. Here's a couple others. Same thing. This one and this one were within 6 feet. This one was like 69 inches. So I know if they'd have moved it 3 inches over, it probably would have been all right. But I wrote both of these up. A master closet. I don't know why you need a sink in a master closet. I'm happy to walk to my kitchen for my coffee. But at any rate, they have their coffee pot in here. There's a sink. It's not a bathroom. Why isn't it a bathroom? Because it only has a sink. It doesn't have a toilet, a bidet, a shower, a tub, or anything else like that. So this is not considered a bathroom. But these are obviously within 6 feet. Well, that's a switch. This is obviously within 6 feet of the sink. So that needs GFCI protection. A wet bar. It's within 6 feet of the sink. It's got to be GFCI protected. If there's a receptacle on the back side of this wall and you measure from the edge of the sink around the corner to that, then technically that receptacle should be GFCI protected. One more quick thing about this. 2017 had wording in it that said through a door, cabinet, partition, something like that. Something to that effect. I think it just said through a door. It was not to be measured through a door. They took that wording out. So if there was a door here and it went around the corner and you measured through the door, it is still required to be GFCI protected if it was within 6 feet of the sink. So the door provision is no longer. All right, laundry area. Once again, the SOP does not require you to call out the absence of GFCI protection in laundry area. However, the NEC started requiring that a few years back, 2014. My comment says that GFCI protection was not provided in the laundry area, so on and so forth. And then I have in parentheses, 2014 NEC. That way I don't get a call later saying, hey, when was this adopted? Or when was this required? It puts it in the report. They know. Now, if it's after 2014, I don't put that little date in there. So a laundry area. What is a laundry area? We had this discussion on Facebook a few weeks ago. Does this mean the entire room? In my opinion, yes, it means the entire room. And here's why I came to that conclusion. A closet could be considered a laundry area, but a closet is not a laundry room. That's why, in my opinion, they called it a laundry area. So if you cross the plane of that door and there's a receptacle to the right, and the washing machine is still 10 feet away, then in my opinion, in my interpretation of the NEC, that receptacle should be GFCI protected. Anything in the laundry area which can be considered a room or a closet. So. All right, how do you test them? Sorry guys, got something going on here it's in my way. There we go. That's what I'm trying to do. All right, how do you test a GFCI? The manufacturer says you test the GFCI by pushing the button. Most of us, I'm sure, carry GFCI testers. I use the GFCI tester to determine if a receptacle downstream of the GFCI is GFCI protected. I don't test the GFCI with the tester. Manufacturer says to push the test button. So it could be on the breaker. It could be on receptacles. And now we're seeing faceless ones put in the garage a lot of times. I had one day, there were 4 of them next to each other. Disposal was one, master bathtub was one, dishwasher was one, and the 4th one was exterior. None of them were labeled. So I noted that they needed to be labeled. But at any rate, that's how you test a GFCI. You do not test it with a tester. You test it with the test button on the device itself. All right. Any questions regarding GFCIs right now? Kenya, are you there?
Yes, I'm here. We have a bunch, but let me go through some of them.
Okay.
One
Yeah,
of
and if
them
you
was
can't get to all of them, just send me the list and I'll answer them.
Okay, yeah, I'll send you a document and then maybe we can email them the questions or something.
Yep.
I mean, the answers. The strict grandfather GFCI protection.
The what?
The strict grandfather GFCI protection. Not sure what I mean.
So no, because your SOP says that you are required to note the absence of GFCI protection in those specific areas. So no, TREC doesn't grandfather them. the way I look at grandfathering is you're required to note the absence of GFCI protection in all of these areas. If the buyer of that house or if your client wants to grandfather it, that's their decision. It's not my decision. It's not Trek's decision. That's your client's decision if he wants to grandfather something. In other words, if he wants to leave it alone, if he wants to disregard your recommendations or Trek's recommendations, then that's their business. They're the ones that are going to determine if it's grandfathered or not me.
Okay, next question. If there is no receptacles outside unfinished places, do we call it? It was outside / unfinished places.
I'm not exactly sure what they're asking, but you are required to have a receptacle at any outdoor equipment, such as mostly we're talking about condenser units there. And you're required to have a receptacle at entrance and exits. So typically front porch and back porch. Sometimes there'll be a side entrance on a garage and you should have a receptacle there, as well as lighting at those same locations. And if it's outside, then yes, it should be GFCI protected.
Okay. The GFCI AFCI resets are located at the exterior panel. Is this appropriate?
Yes, that's readily accessible. And remember, it said that you can use a key, and that would be, so if the homeowner had the panel locked, then that's acceptable because it says you can use a key to get to it. That falls under readily accessible. So yes, they can be in the exterior panel. Not in my opinion, the best location. And it really frustrates me when you have to walk out in the mud and reset them 6 different trips when you're trying to inspect the inside of a house, but it's acceptable.
Okay, one more here. Is the receptacle for the jetted tub required to be faceless?
That is supposed to be a dedicated circuit, so technically yes. But I see them all the time where they have a typical GFCI receptacle to protect that tub. Now, that being said, I don't get too concerned about it because what are you going to plug in there that's really going to cause an issue? Technically, it's a code violation, but once again, not a huge issue in my opinion.
Okay, last one here. How do you call out when 2 GFCI are wired in series?
I note it as a nuisance. It's not a violation, but it is a nuisance because you trip a GFCI and or you trip a GFCI with a tester downstream of the GFCI and you go back to reset the GFCI and it won't reset because the one upstream of it is. So I note it, and I simply say it's not a violation, but it is a nuisance or could be a nuisance.
Okay, perfect. Thank you.
All right, ready to roll?
Yep.
Okay, cool. All right, AFCI, and this is the document I was talking about. I'll share this later as well on Facebook so y'all can have this. So AFCI protection, this is the newest wording, and it is all 120 volt single phase 15 and 20 amp branch circuits supplying outlets or devices installed in dwelling unit, kitchens, family rooms, dining rooms, so on and so forth. This is the exact wording out of the NEC. It's also in the IRC, but I use this exact wording if I happen to find something that is not provided proper protection. And then I note on the tail end of this comment where the AFCI protection was not provided. And I may be very specific. The back right upstairs bedroom was not provided this protection, or I may be just put a general statement in there depending on how many circuits didn't have it, such as several of the above mentioned rooms were not provided AFCI protection because sometimes it's just totally wrong. And sometimes it's just 1 or 2 rooms or circuits. Now, that being said, we are not required to note the absence of them in all instances. What I do is note the absence of AFCI protection per the year of construction. So if it's prior to, we'll go back one slide, 1999 when they were introduced, and there are no AFCIs, then I don't note it. I don't say anything about the AFCIs. If it's from 2002 to 2008, then I'm only looking for them in the bedrooms and so on and so forth. So if I go to a house and it's built in 2014 and the only place to have AFCI protection is in the bedrooms, then I'm calling all that out. I'm noting that the absence of AFCI protection was noted in several circuits throughout the house. The inspector, this is from the SOP, the inspector is not required to test arc fault circuit interrupter devices when the property is occupied or damage to personal property may result in the inspector's reasonable judgment. So it doesn't say you can't, it says you're not required to. And typically I follow that line. If it's occupied, I don't trip them. If it's unoccupied, I trip them. You're not required to note the absence of AFCI protection, just like I was talking about. But once again, if you have that little chart, it won't take you long to memorize where they are required. And then you can note it per the year of construction. When are you required to add AFCI protection? Where branch circuit wiring is modified, replaced, or extended, the branch circuit shall be AFCI protected. AFCI protection shall not be required when extension of the circuit is not more than 6 feet. In other words, if you add on to a circuit, if you add, say you added a room on the back of your house, or the client added a room on the back of their house and they tied into the living room circuit, if they extend that circuit 6 feet or more, then they're required to add AFCI protection. There is a misconception that when you replace a panel, you're required to update AFCI protection. There is no requirement. I've got it underlined here. Addition of AFCI protection is not required with a panel replacement. Can you? Yes, you can. Are you required to? You are not. The only time you're required to add AFCI protection is if you add, extend, or release 6 feet or more of a circuit. At that point, you could put a breaker in, or you could use an AFCI receptacle. All right, pigtail or no pigtail on the AFCIs and GFCIs and dual functions. So the panel on the left, this one can be, actually both of them can be done both ways. There are breakers designed to latch onto this neutral here. It latches onto the hot, but then there's a device inside the breaker that will latch onto here. That way you don't have the pigtail coming out. This one, they ran all the pigtails back around from, so you go here and then your pigtail comes around. I think I just said that backwards. Yes, I did. Sorry. So there are two different ways. You've got the ones that don't have the pigtail. This little piece right here will latch on to the neutral. So it makes a much cleaner panel, especially the panels that have all the curlicues in them. You don't have all those curlicues in there. This latches on to the neutral so you don't have that additional wire like this right here, this little pigtail. So that either way is acceptable, but the panel has to be designed obviously to accept the one that doesn't have the pigtail. Much, much cleaner design. All right, how about AFCI receptacles? We're going to touch on this just briefly. I've seen it twice. I know Ray Horn has seen it one time out in El Paso where they used AFCI receptacles. I've seen it where they used AFCI receptacles and then AFCI, GFCI combination, dual purpose receptacles. There are instances where you can use these. there are restrictions. It has to do with the length of wiring from the panel to the first outlet. There are some other exceptions and rules that you have to follow. We're not going to get into them because we very rarely see these. I just wanted to touch on this. So if you do see an AFCI receptacle, you know where to go look. 21012. And it's kind of confusing, as most of the NEC is. It's kind of confusing when you can and can't use them. But the main thing that I've found is the length of the wire feeding the AFCI cannot be over a certain length. And and it's dependent on wire size. 14 gauge is one length, 12 gauge is another length. So if you see AFCI receptacles, raise a question. Any questions regarding AFCIs?
We have a couple here. The first one, does coiling up the neutral wire like some contractors do create any type of issue?
The curling, like on that one, no, it doesn't do anything. I'm assuming you're talking about this. That's the way it comes from the factory. Some of them come straight, but Square D, obviously, they come with a curled pigtail, and it doesn't do anything. That wire is the same length, whether it's curled up or if it's stretched out straight. So no, it doesn't cause any issues.
Okay, next one. Which panel manufacturers allow AFCI breakers without pigtails, or do they all allow both?
Ooh, that I cannot tell you. I don't know which ones do or don't, but and I don't even know how. It's just something you have to learn to look at the panel and see that it's designed to accept the breakers that don't have the pigtails. I'll try and find something and post it on Facebook on that over the next couple of days, but I don't have a list of who does and who doesn't. I would assume that GE, Siemens, Square D, and Cutler Hammer all have the pigtailless breakers by now, but I can't swear to that. But those are the four main ones. Oh, Leviton, that very first picture, I know they have them. But I would assume that the major manufacturers all have them at this point. It makes for such a clean panel.
Okay, last one over here. Have you seen any new construction homes with no trip buttons? DR Horton is doing this.
With no trip buttons? No. Whoever posted this question, get a hold of me because I want to talk to you about this. This doesn't seem like, I haven't seen a breaker or a GFCI that doesn't have a trip button or a test button. So whoever posted this question, please get a hold of me. Either call me or text me, email me, Facebook, however, because I want to see this, and I hope you have some photos of this because that's a new one on me.
Okay, thank you, Derrick.
All right. All right, flush mount installations. Now, this is not a specific requirement in our SOPs, but I typically check this in new construction and something or somewhere where you could tell that somebody added something like shiplap in a house. So you are the receptacles required to be, or the junction box rather, is required to be mounted flush with, it's mostly if you're looking at flammable materials on the wall surface. If it's a non-flammable material such as tile, gypsum, plaster, concrete, so on and so forth, then it can be set as much as a 1/4 inch back. If it's more than a 1/4 inch on the non-flammable surfaces, or if it's not flush with flammable surfaces, then you need to add a spark ring or a box extender, such as this. So that one on the left, you can see it's set back more than a 1/4 inch. Same way down here, it's set back more than a 1/4 inch. So these little boxes, they're open on both sides, are designed to slide into there the ears hit the tile in the perfect world, because that tile guy is going to cut everything exactly perfect. And then everything will sit flush. You put your cover plate on and you go on from there. I don't check this in every house. Like I said, I check it in new construction. I get more tedious on the electrical in new construction just because it's new construction. I go beyond the SOP, in other words. Or if I find where they've added wood or some other type of material onto the surface of a wall. And a lot of times if it's shiplap, or I've seen them do horizontal 1x6 cedar where they overlap, they put it on like shingles. So there's a good 3/4 inch gap. So anything like that, I'm going to note the absence of it. All right, AC disconnect. Thank you for the photo, Russell Johnson. A disconnector is required within sight of the unit. Well, the disconnect's there, but they disconnected it for some reason. So that's a pretty obvious one. Here's something else down here. It doesn't have anything to do with electrical, but it looks like it's sitting on old 2x6s. A disconnector is required within sight. Once again, the breaker or the overcurrent device can serve as the disconnect if it's within sight. And what does in sight mean? It means within 50 feet. Disconnecting means shall be located within sight from. If you go to the definitions in the NEC, within sight says direct sight, direct line of sight, within 50 feet. Has to be readily accessible from the air conditioning equipment. Readily accessible means that you do not climb over the condenser unit to disconnect. It can be installed on or within the air conditioning equipment. It cannot be installed on that panel that you remove to get to, say, the capacitor. In other words, it can't be, whoops, it can't be installed on this panel right here. It cannot be installed, say this was the label. You can't put it over the label. You can't hide the model number, serial number, refrigerant type, the breaker size, so on and so forth. So it can be on the unit, but it's restricted where it can be put on the unit. How to decipher wire and breaker sizes. Determining breaker size and wire size for condenser units. Your minimum circuit amps will determine the wire size. Your max fuse or breaker size will determine the breaker size. And I've got some labels here to explain that. Max fuse or circuit breaker, 50. That breaker, and on this one, it has a min. Very few of them I find have a minimum. You've got anywhere from 40 amps to 50 amps. So the breaker, and it says it right there, breaker, 40 to 50. Minimum supply current ampacity, 34. So the 34 10 gauge NM wire would not work because 10 gauge is rated for 30 amps. So you would have to go to 8 gauge. Doesn't matter that 8 gauge is not rated for 50 amps. What matters is what this label says. That's your wire size, the one in blue. Your breaker size is highlighted in yellow. Here's another one. Max fuser circuit, 15. Minimum circuit amps, that determines your wire size, 10 amps. You could run 14 gauge wire on this. That's got to be a small unit. Once again, on the bottom one, 40 amps. That's your breaker size. Very rarely do I see the wire. It's very, very common to find the breaker oversized, especially when the unit's been replaced, because the units are getting more and more and more efficient. So the breaker sizes don't have to be as large as they used to be. So the AC guy doesn't go look at the size of the breaker. He turns it off. He puts the condenser unit in, wires everything up, and he turns it back on. So I would say 80 to 90% of the time when the unit's been replaced, I find that the breaker is the wrong size. 440.22C, where maximum protective device ratings show on a manufacturer's overload relay table, the protective device rating shall not exceed the manufacturer's value marked on the equipment. That is directly from the NEC. So in other words, it needs to match that breaker size. Now, on the flip side, if I find a breaker that is too small, say that the max fuse, well, let's take this bottom one. It says 40. If I find a 30 amp breaker connected to that, it may not be necessarily a deficiency. What I put on the report is that the breaker was undersized per the maximum allowable, and that nuisance trips may occur during peak run times. And then that way the client can decide if they want to address it or wait and see what happens in August. Insight from, and as I touched on this a little while ago, this is the definition from the NEC. Where this code specifies that one equipment shall be insight from, with insight from, or with insight of, and so forth, another equipment, the specified equipment is to be visible and not more than 15 meters, 50 feet distant from the other. Now, there can't be a 6-foot privacy fence in between. I would suggest that a wrought iron fence that you can see through or over clearly would be okay if there was access through there. But if you had to walk around the other side of the house, I would suggest that is not. I want to be able to get from the condenser unit to that disconnect within sight. And typically what we're talking about within 50 feet, we're going to talk about the breaker as the disconnect. If it's got a secondary disconnect, it's normally right there by the unit. All right, any questions regarding AC disconnect, wire sizing, or breaker sizing?
I have one over here. It says, so the wire and breaker not being aligned isn't an issue? Are you measuring the wire gauge and do you recommend a certain tool? None seem accurate enough to me.
I don't use a tool to measure wire size. I have been doing electrical since I was 8 years old. My grandfather was an electrician, so I can look at a wire and tell you the wire size. It's just something that you have to learn over the years. And the problem with using gauges is aluminum wiring, especially 1-gauge wire, will be 3 different actual measurements, because there are, I can't think of the term right now, but it's more or less, it's loosely twisted, then you have one that's compacted, and then you have one that's compacted even more. The other thing is, if you're measuring, say, NM Romex against a multi-strand wire, that may be a little bit different too. A different manufacturer, and you have to measure the actual wire. The manufacturers, the sheathing on it may be a different size. So wire sizing is just something that you have to learn, and it just takes experience, I guess, is the best way to look at that. Go to Home Depot and go buy 6 inches of several different wire sizes and keep them with you and have them clearly marked. The other way you can look is most of it's labeled. You can look at it and see the wire size, depending on how much is accessible. Obviously, if it's in a conduit, you can see barely any of it. Some of the wire is color coded nowadays. Orange is number 10. White is 14, yellow is 20. 12. So, but you go to older construction and all that's out the window. So learning wire sizes is just going to be experience. The other half of that question, the wire size not rated for that breaker size, if the wire size and breaker match the label on the AC, then that's fine. If it says, we'll go back to this bottom one, says 40 amps and minimum circuit amps is 24. So you would have to use 10 gauge wire on this because you go up to the next rating, which would be 30 amps. Well, they don't match, and that's perfectly fine. This is what you're looking for right here and right here. Although 10 gauge wire is rated for 30 amps, it can go on that 40 amp breaker because that AC manufacturer said so. There's protections in the unit itself that take care of that. So don't call it out if these wires don't match the breaker size. Unless, now if they had 12 gauge wire on here, it's an issue because 12 gauge is only rated for 20 amps and you need 24.4. Now, to add on to that, we talked about labeling earlier. If nothing's labeled in the panel, you don't know what that 40 amp breaker's feeding. So if it's connected to 10 gauge wire, then you absolutely need to call it out. And if you remember in that comment that I had, it specifically called out the air conditioner breaker or the condenser unit breaker, such as the condenser unit breaker, because if it's not labeled, I can't verify that the manufacturer's specifications meet the requirements of the wire size. So that's the two numbers you need to look at. And on the top one, it's a 15 and 10.3. That's what you look at. The wire size is dictated by the air conditioner manufacturer. It's not dictated by the NEC. I hope that answered that. If not,
Okay,
get a hold of me and I'll answer it some more. Okay, go ahead.
Okay, last one here. Where is single strand and multi-strand aluminum allowed?
Okay. Multi-strand is obviously permitted for main service because we see it almost every day. To my knowledge, single strand is not manufactured anymore. I could be wrong there. I would suggest that if you see it in new or newer construction, that you raise question about it. I was in a house about 6 or 8 years ago. They had added on a garage and they had used aluminum wiring in it. And I asked them, where did you get the aluminum wiring? This was single strand aluminum wiring, 12 gauge wire. And he said, oh, my dad was an electrician. He had it in his attic. So I noted the presence of aluminum wiring. It's still permitted to be used between panels from a main to a sub. It is permitted on larger circuits such as ranges, so on and so forth. Most builders, most electricians are using copper. Where I find issues with aluminum is late 60s, early 70s when they used it a lot. When I find that, I randomly sample receptacles, switches throughout the house to determine if they've been updated in a suitable manner. There are about 4, there used to be 3, now there's either 4 or 5 different suitable manners. Well, it's actually 2 acceptable manners. There's a pigtail or the device has to be labeled. adding the pigtail, there's different ways of doing it. So typically it's 2 ways, pigtail or a newer device that is rated for aluminum. And the aluminum wiring is acceptable in those older circuits if it's been updated. So I hope that answers that. If not, like I said, keep saying, get a hold of me and I'll try to enlighten you. So any more questions, Kenya?
I guess we can have one more and then I'll send you the other ones. This one says, does the wire size include the width?
Oh, the whip. Yes. It's from the connection at the condenser unit. If it's the whip to the disconnect and then to the breaker panel. And so that brings up a good point. You need to open those disconnects and look at them. Sometimes they're hard to get open. Sometimes you can't because they've caulked them to the brick. Sometimes you can't get into them just the way they're designed. If you can't get into them, I would suggest that you did not open it and look at it. The other reason you need to look in there is to make sure they didn't bypass the disconnect. I find that a couple times a year where the disconnect went bad, so they just wired around it. Or I have found where they will tie into that disconnect to add a receptacle. You're not supposed to do that. So yes, the entire run of wire should meet that requirement. All right, bathtub and shower enclosures. For some reason, I could not get this slide to be clear, but you can Google this image on the internet and pull it up. But pretty much the only thing that could go over a tub is a recessed light within 3 feet. And it's measured from the top edge of the tub. It's not measured from the floor. So I take that back. You can put something else over it, but it cannot be within 8 feet. Sorry, I said that wrong. So this is a great little image to have. And I keep this on my phone because I come across this on occasion, but not enough to remember the exact numbers. So once again, just Google this and you can find this. There's 3 or 4 different ones out there. So just make sure there's nothing hanging over a tub or a shower, such as these. Nice little fan up there. The picture on the left, I guess I cut it off, but there's a chandelier over that tub, a huge one, and it was within 8 feet. So definitely call those out. You're standing there drying off, you reach up and hit it and zap. Not designed to be over a tub. All right, integrity of electrical equipment and connections. So internal parts of electrical equipment, including bus bars, terminals, insulators, so on and so forth, shall not be damaged or contaminated by materials such as paint, plaster cleaners, abrasive, corrosive residues. And it doesn't specifically mention it on here, but nest, dirt daubers get in these things. I've opened some up that were so full of yellow jackets and red wasps that I left the cover off. I said, I'm sorry, I'm not putting that back on. We're calling an electrician. I'll ease up there and shut the main door. But I've seen some that are just packed full of stinging critters, and I'm not going to mess with those. So, and then shall be no damaged parts that adversely affect the operation or mechanical strength of the equipment. So if they've cut into it to add a piece of conduit where they didn't use the knockouts, if they modified the bus bars in some way, anything where they modified that panel, you should call it out. The biggest one that I see is probably paint, and I call that out quite often. Very rarely do I ever hear if they cleaned them or replaced them or what, but nobody ever calls back and says, hey, come look at this to see if it's good. Nobody ever has, so that's up to them. But you got all these wasps in there. I call those out. That panel just needs to be cleaned out, free of debris. That rat ended his life in Pasadena one day and just stayed there. That's contaminated. You can obviously see he's been in there a while because there's some pecans that have been eaten. Corrosion. This panel, whoops. I inspected this house twice, both within almost a year of each other. I got to it that second time to do the inspection, opened the panel up, and there's corrosion everywhere. So I pulled up the previous report from a year earlier, looked at the photos of the panel, not one speck of corrosion in there. There was no pool. I called the agent, and it was actually her sister that was selling the house. I talked to her just to try to get information for the buyer. Did they have a pool here at one point? Did they have an above ground pool? No. I said, all right, they have a septic system. And she goes, I just talked to my brother-in-law. He said they stored the chlorine for the septic system directly under this panel. So this is what 1 year of storing chlorine under a panel did. It doesn't take long. The buyer was an electrician, so he wasn't too freaked out. He said, I'll deal with it. But I put in my reports, if there's a pool or septic, I put a comment in there about storage of chlorine or other corrosive materials, just to give them a heads up. I've seen water heaters completely destroyed by chlorine. It goes airborne and it eats away at stuff. So if you see corrosion, especially like this, that's contaminated. Definitely needs further evaluation and possibly replacement. Paint. The one on the left, obviously the hot bars are painted, so you're not going to get good connections with your breakers. So somebody was asking earlier about how would you know if a panel was would accept a pigtailless breaker. This one won't, because the neutral doesn't carry up here. You just lock on over here. That's the back of the breaker. There's not a bar here for the breaker to lock onto. Sorry, we're jumping around there, but just want to throw that out there. But that one's obviously, it says clean or replace. I would suggest that one probably can't be cleaned right. This one, there's paint everywhere. There's not a speck of paint on the breakers. So what's likely behind the breakers? Paint. So I'm calling this out as contaminated. Barriers. Now this is a 2017 code. I do not call this out on older construction. I call this out on 2017 or newer. These little guys here, the yellow, this is the one I found the other day where the backfed breaker has the barriers on there. GE, they're clear. Cutler hammer. The little holes in them, that's so you can test. Your tester will fit through there. They shall be placed on all service panel boards such that no insulated, ungrounded service bus bar or service terminal is exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations. This is required on the main panel only. It's not required on the sub panel. And the reason it is because it says ungrounded service or service terminal, service bus bar or service terminal. These are your service terminals. In a sub panel, that's not a service. This one, if you stand upside down on your head, then it's right. But they put this on the outgoing instead of the service. They should have been up here on these top ones. So the electrician did a little drinking the night before, I'm assuming. But once again, I look for these in 2017 or newer. I don't call it out on older construction, or if it's a panel replacement, I'll call it out. All right, backfed breakers. Plug-in type overprotection devices that are backfed shall be secured in place by an additional fastener that requires other than pull to release the device from the mounting. In other words, if you can walk up here and pull that breaker out, then it's not secured. But this screw right here, you remember the one earlier had the hole in it because it didn't have the screw in it. That's your hold down. You can't pull that out until you take the screw out. That's what this means right here. This one, you got a plastic connector. This is a Cutler hammer over here. It's a different design. Or excuse me, Eaton Cutler hammer, they're pretty much the same. But this plastic clip, you take that screw out, the plastic clip comes out, you can remove the breaker. Once again, it takes more than just pulling. Has to have a device to keep it in place. Oh, here's that same picture. The hold down's missing. Need a screw in here. Right there. Simple to add. You can't just put a drywall screw in it. I wouldn't put it past somebody. Has to be the screw designed for that. All right. And we've talked a lot about code throughout this presentation, but sometimes you don't need a code. You just say, hey, this is wrong. Such as this right here. You remember the presentation or the slide at the beginning of the presentation where they built the trellis over the panel, over the meter and the main panel? Well, this is up toward the top of that pole. They ran conduit up there, ran the lines out of it, and siliconed it. I don't care how much silicone or how often you put silicone on there, water is going to get into that conduit and it's going to come right down into the panel. So that obviously was not done. Should have had a weatherhead put on it. This one over here, you got a splice with a nail in it and a screw in it. Just use the right size connector, the right size splice, and you don't have to cram other foreign matter into the splice to make it a tight connection. So those are pretty simple to call out. The other thing, you can see all the debris in this panel. We talked about contamination. You got all kind of critters running around in here. Spider webs are flammable, combustible. So are spiders if they get dried out enough. So call this out as needing to be cleaned free of debris. You see all this down here, that's fecal matter from critters. Grounding electrode system. We're not going to get too deep into grounding and bonding because I have no hair left to pull out, but we'll touch on it. Mostly what we see around the Houston area are ground rods and my mind went blank. CEEs, concrete encased electrodes. Sorry, I should have drank one more cup of coffee. So a supplemental electrode is required. A single rod, pipe, or plate electrode shall be supplemented by an additional electrode. If there's a CEE and it's installed right and you have contact with earth, a supplemental is not required. So there are instances where you could have a concrete encased electrode and you don't have to have anything else. You have to have access to that connection to the concrete encased electrode though. If a single rod, pipe, or plate has a resistance to earth of 25 ohms or less, the supplemental electrode shall not be required. So this is what I note on most reports, that a second ground rod is required unless it can be verified that 25 ohms or less of resistance is provided. I do not measure it. In my opinion, that goes beyond the scope of an inspection. I know there are some inspectors that measure that, but I'm not getting into that can of worms. I simply note that there was one, there should be two unless the 25 ohms of resistance is met. That's a judgment call that you have to make, that you want to make. I also note that if I see a concrete encased electrode, that here in the Houston area anyway, because we have plastic under our foundations. I know there are some parts of the state that do not have plastic under their foundations because it's so dry. I note that it may be ineffective. And then I recommend the second ground rod on top of that, just because I don't know if the CEE is doing anything, and I don't know if the single ground rod is meeting the 25 ohm resistance rule. If you add a second ground rod, then the rods or plates or pipes, I'm saying rods because that's 99.9% of the time, that's what we see here. Then they have to be a minimum of 6 feet apart. They can be in series or parallel. In other words, you can run from the service panel to a ground rod, and then that same wire can extend 6 feet over to the second ground rod, or you can run two separate ground wires from the main panel to one rod and then from the main panel to the second rod. Either way is acceptable. The electrode shall be installed so that at least 8 feet of length is in contact with the soil. There are exceptions to allow the rod be driven at an angle. So you guys in the hill country and rocky areas of the state, y'all need to know those exceptions. Obviously, you can't see underground. You can't see how long it is. You don't know if it was an 8-foot rod to start with. You don't know if they used a 10-foot rod. If you get to a house and you see that there are saw marks on the top of that rod, I would certainly say something. It appears that the rod was cut off, so it may not be within it may not have 8 foot of contact with soil. Always check them. I pull on the wire. I push on the rod with my foot to make sure that there is some integrity to the rod still. If it's a pipe, you have no way of knowing how long it is. It might be 2 feet long. It might be 12 feet long. I just make a comment about it, unverified. Obviously, you want to make sure that it's connected. The one on the left, it's not connected. It's just hanging out there. The one on the right was from Eric Christie, and I thought that was a video, but obviously it didn't do anything. He pulled that rod out of the ground and it was about 8 or 10 inches long. So I typically won't grab them with my hand just in case. I'll grab the insulated wire and pull on it, usually just with my foot, give it a good tug or push over on it like this. So that one obviously had issues. I don't know how long it was, but it was not structurally intact any longer. So I definitely wrote that one up. That's pretty easy deficiency, but I always kick them, push them, pull on the wire, something, do something to see if the integrity is still there. I know Mike Cawthorn has shown me pictures of a few that he's pulled straight out of the ground and be less than a foot long. Bonding of the main conduit entrance. Now, I skipped over something back here. Your SOP, report as deficient the absence or deficiencies in the grounding electrode system. And it also, I guess I didn't put it in here, but this is grounding and bonding. Now, this obviously was not required years ago. This was, I think, 2011 NEC edition. I noted on most reports, the way the SOP is worded, it's kind of vague on bonding and grounding. So I note this, and this far one on the right is typically, I put this photo in my reports as an example, because if you just tell them that it needs a bonded bushing, they're not going to understand it. So you put the picture in, they say, oh, okay, that's fair enough. The one in the middle I put in here so I could show you. You see how this one is hinged. So this can be added. It can be retrofitted. It doesn't have, you don't have to disconnect the main service wires. Electrician can come in here. He can get the plastic fitting off. You take this screw out, it's hinged. It goes around there. You tighten that screw down and you hook your wire, your bond wire. So if the realtor, the electrician, the seller, whoever says, I can't put that on, I gotta call the service provider to come out and disconnect the meter. No, you don't. You can add this without removing these wires.
Hey, Derek, sorry to
Yes.
interrupt. Just wanted to
ahead.
let you know you have about 10 minutes until the class needs to end.
Okay, I think I'm almost to the end. So an inter-system bonding termination. I only note these on new construction. And there's a couple of reasons why. Typically on older construction, the low voltage guys have already been there. If it's a resale, internet guy's been there, alarm guy's been there. They have attempted to bond somewhere anyway, onto the CPVC up in the attic. So it doesn't make a lot of sense to call this out on a house that's been around for 20 or 30 years, because those low voltage systems are already there. The other reason I don't call it out is because in the NEC, it says that this is not required to be added during a panel switch. In other words, if you replace your electric panel, you're not required to add this. Now, I do see it added when they do a panel upgrade, but those are the two reasons I don't call it out. I call it out on new construction. So, and once again, that's the way I do it. Everyone has their own ways of doing things. So if you have a different opinion on it and you want to call it out on everyone, feel free. But I have documentation that I can use to back up my opinion. And with the IBC or IBT, it shall be accessible. So typically it's outside by the panel. It shall have at least 3 terminals where you can connect 3 wires. This one has 4, 1, 2, 3, 4. It shall not interfere with other equipment. It shall at main service or building disconnect and shall be secured to the structure or GEC. There is one design where it just connects to the wire. It doesn't have any ears on it like this. It just connects to the wire, and then there are 3 other connectors on it. So, and it's got to be listed. I mean, that goes without saying. All electrical equipment shall be listed. And there's the exception I was talking about. It may not be required on existing buildings or structures. So, hey, perfect. Any questions?
Perfect. Yeah, there's a couple here. I think this one was from the previous section, but still it said, how do you know if it needs to be a backfeed breaker?
How do you know if it's a backfed breaker?
If it needs to be a backfeed breaker.
Well, okay, so a backfed breaker, so typically you would have a breaker sitting up here that would be a main. And the wiring would come in up here and then down to the hots here. And so let's take this breaker, these 2 15-amp breakers here. Electricity is going out of that breaker through the wire, right? With this one, it's going the opposite way, so it's backfed into the breaker. Most breakers, the electricity comes in this way because you got a main up here. The electricity starts here and goes here. A backfed breaker, the electricity starts here and goes into here. So it's just a matter of placement of the breaker. If this breaker was up here and the electricity came in and hit the breaker and then to the hot bus bar and then out into this breaker, that's not a backfed breaker. All that means is it's the electricity is flowing the opposite direction. It's flowing backwards in a sense through the breaker, which electricity will flow either way. The device will trip either way. It's just, it's not knowing if you need a backfed breaker or not. It's knowing if there is a backfed breaker or not a backfed breaker. If the electricity is flowing through the breaker to your hot bars here, it's backfed. Okay, go ahead, can you?
I guess the last one before I have to give them some announcements.
Okay.
It says, do you write up electrodes that are visible solely on the assumption that the full 8 feet is not in contact with the earth?
No, now if it's sticking up a foot, I note that it was likely not because it's a foot of it's not been driven in. If it's driven flush with earth and it doesn't look like it's been cut off, then I don't say anything. It's mostly a visual inspection. It's like writing up that wiring inside a wall is possibly damaged. I mean, you can't see it, you can't report on it, so no. But if I can move it like that one in that video I showed, or the one Eric Christie had where he pulled it completely out of the ground, yeah, it's definitely an issue. But if it's flush with the ground, and I didn't touch on this, but if the connector's rated to be in contact with earth, then I don't note anything.
Thank you. Is there anything else you want to add?
I don't. I will just say that I enjoyed it. I hope everybody learned something. I hope you're not confused. I know electrical can be very confusing. And like I've said many times, if you have any questions, get a hold of me. My telephone number, my email, Facebook. I'm friends with a lot of y'all on Facebook. I'm trying to get back to the beginning right quick so y'all can see my phone number again. But yeah, get a hold of me and I'll be glad to answer any questions. I try to stay on top of the Facebook questions, and I know there's sometimes I look at it and I think I'm going to let somebody else answer this, but I try to answer them the best of my knowledge. And I will say this too, that Jim Heim taught me this years ago. Anything that I write up, I try to have some type of third-party documentation that I can refer back to and say, this is why I wrote this up. Whether it's the NEC, the IRC, a manufacturer, Trek, anything that goes in that report, I have something that I can say, well, this publication right here is the one that said you can't do this. Or this publication is the one that I referenced because this is wrong. So putting out an opinion out there on a report can get you in muddy water. One that I've seen before is a receptacle was too close to a hose bib. There's no violation there. If you want to mention it, but do not write it as a deficiency. But something like that. If I can't refer back to the NEC, I'm not noting it. So anyway, once again, thank you, everybody. Thank you. I enjoyed it. I hope y'all did too. So.
Thank you. We have a lot of positive comments here.